Let's look at another example where we're going to see if something is a Riemann integrable function. And so our function here is a funky function. So we have g that's going to map from the closed interval 0, 1 to the real numbers. And it is going to map in this way. So if we have a rational number, if x is a rational number, then it's going to map to 1. If it's irrational, it maps to 0. So here we could say, let P be any partition. If P is any partition of 0, 1, then since each subinterval is going to have both rational and irrational numbers, since every single subinterval is going to have both rational and irrational numbers, then the largest function value on the ith subinterval will always be 1, and the smallest function value on the ith subinterval will be 0. No matter what interval you have, those will be our largest and smallest values. Thus, the upper sum is going to be sum I equals 1 through n, m sub I, delta x sub I. But all of these m sub i's are 1, so we just have a sum I equals 1 through n of delta x sub I. When we add up all the widths of the subintervals, since they are partitioning 0, 1, it should be the length of that interval, and so it's going to be 1. And we will also have L of g comma p equals a sum I equals 1 through n little m I delta x sub I. But all of those are going to be 0, so that lower sum is 0. And that's for both of those, that's no matter what partition you choose. And so, because of that, we end up with our lower integral is equal to 0. We end up with an upper integral that's equal to 1. Those two values are not the same. And since those two values are not the same, we have G is not Riemann integrable. Nice. Then the last thing from this section we will mention here real quick is this theorem, which says if f is a bounded function on a closed interval a to b, it is integrable if and only if, so f is integrable if and only if, for every epsilon greater than 0, there exists a partition P such that the distance or the space between the upper sum of that partition and lower sum for a partition is less than epsilon. So for every epsilon, there is a partition that will satisfy the distance or the difference between the upper sum and the lower sum is less than epsilon. All right, that is it for this section. In the next section, it'll be real quick, and we're just going to look at some properties of the Riemann integral. We will talk to you then.